Example 4 is going to be about a couple that has saved for retirement and now they are retired and they want to start taking money out of their retirement account, okay? So once you retire and you start taking money out of your retirement account, that is a classic example of having to use the present value of an annuity formula, okay? Because you will be receiving regular payments out of your retirement account. Okay, so let's go ahead and read the problem. At the time they retire, a couple has $200,000 in an account that pays 8.4% compounded monthly. If the couple decides to withdraw equal monthly payments for 10 years, at the end of which time the account will have a zero balance, how much should the couple withdraw each month? Okay, so when you read this problem, okay, keep in mind the couple has already saved their nest egg. They have $200,000 in their retirement account, okay? And now they're retired and they're ready to start receiving retirement payments out of this account, okay? They want to withdraw equal monthly payments for 10 years and they want to bring the balance down to zero, okay? Your first thought, and I want to clear this up very quickly. Your first thought, let me get my calculator here. Your first thought may be, well, okay, they've got $200,000, okay, and then they want monthly payments, so that's 12 payments a year for 10 years, so that's a total of 120 payments. You may be thinking, well, why don't they just take the $200,000 and divide by 120 payments, okay, and that's how much they're going to receive every month, okay? This is not how it works. Why? Because, okay, say it's time to make, to receive the first payment. Okay, so they got $200,000 in the account. Okay, we're trying to figure out how much they should withdraw each month. Okay, whatever that amount is, remember, they're going to receive a check for that amount. Okay, but there's still a huge amount of money in their retirement account, and that money is going to continue to earn interest, okay? Because the money that is still in the account is still going to earn interest, you cannot do the problem like this, okay? You can't just divide out, okay? Because that doesn't take into account that the money that is still in the retirement account is still earning interest, okay? So because of that, you're gonna have to use a formula on it, okay? So again, this is an annuity, okay? The couple, it involves regular payments to the couple, okay? Because remember, annuity is a regular sequence of payments, okay? The reason that this is present value of an annuity and not future value of an annuity is because the annuity is being paid out, okay? They're not saving money necessarily. They've already saved their nest egg of $200,000. Now that money is being paid out. Okay, so here you've got an annuity being paid out. That makes this present value of an annuity. Okay, so I'm going to go ahead and write down my formula. So remember, on your formula sheet, okay, it's going to be this formula. Okay, so let's go ahead and write that down. Okay, so we're going to have PV is equal to P times 1 minus 1 plus R over M raised to the negative MT power all over R over M. Okay, so that's the formula for present value of an annuity. Okay, so now we need to write down what we know and what we are looking for. Okay, all right, so let's go ahead and write down the obvious stuff. So we know the R value is 8.4%, so let's convert that to a decimal. This is going to be 0.084, okay, and we are doing everything monthly, okay? There's equal monthly payments, okay? So remember, whatever the time frame is for your payments, since it's monthly here, you're assuming that the interest is compounded monthly as well, okay? So those two things should coincide. So our M value here is going to be 12. Everything is done monthly. All right, time is going to be 10 years, okay? They're receiving the payments over a 10-year period. And now we need to decide between P and PV, okay? So remember, for this formula, P is the amount of each payment, okay? So P would be the amount of each payment to the couple. That's what we're trying to figure out. How much should they be receiving each month or withdrawing each month from this retirement account? So that is actually what we're looking for, okay? Present value. Think about what that word means in just everyday language. Present value. How much the value right now, presently, okay? So right now, at the time of retirement, the couple presently has $200,000. So that is $200,000 is your PV here. Okay, so this is the value of all the variables. Okay, so we are solving for P. Let's go ahead and plug everything in. All right, so we're going to get 200,000 is equal to P times all this stuff in brackets. So 1 minus 1 plus R over M raised to the, remember, there's a negative exponent here, so it's negative M times T all over R over M. Okay, so this is how you're going to plug into it. Okay, all right, so we've got to solve for P. Okay, P is multiplied by this big thing in brackets. Okay, so the first thing we're going to do is figure out what that quantity is in brackets. Okay, and then we can go from there. Okay, so get your calculator. Okay, so we're going to punch it into the calculator pretty much exactly like you see it. We're going to start with the most complicated part first. So we're going to start with the numerator and get that answer. And then we're going to divide by the denominator, and that will give us the quantity that P is being multiplied by. Okay, so let's plug it in. Okay, so make sure you can see this. Okay, all right, so we've got, there we go. Okay, so we've got 1 minus parentheses 1 plus 0.084 divided by 12 raised to, make sure you put the exponent in parentheses, so it's negative 12 times 10, close parentheses, enter. This is going to give me the numerator, okay? So remember, you've got to keep all these digits, okay? So I'm going to go ahead and hit the division key so that I can divide by the denominator, okay? So in parentheses, I'm going to put 0.084 divided by 12, okay? Close parentheses. This is going to give me the quantity that is in brackets. Okay, so I'm going to go ahead and write this down. Okay, so we're going to get 200,000 is equal to P times this long decimal 81 point blah, blah, blah. So let me just write it down. Give me a second. Got to keep all the digits here. All right, so that's what you got. Okay. All right, so we've got to isolate P because that's what we're solving for, okay? P is multiplied by this number, okay? So to get P by itself, you're going to divide both sides by this number, okay? All right, so let me write this down. Okay. Hang on just a second. All right, so there we go. So now we just need to punch this into the calculator and we will have our P value, okay? All right, so let me come back over here, okay? So remember, you can, if you choose to, you can just type all the digits in again, but you really don't have to. Let me move this lamp, it's kind of, there we go. Okay, so we're gonna do 200,000, oops, 200,000, okay? Divided by, and you can use that answer feature if you don't want to type everything in. I'm going to hit second answer, okay, and that is going to give me the amount. Okay, so let me go ahead and write this down, okay, with the decimal places. So just over $2,400 a month for this couple. All right, so there's your decimal, okay. So we need to go ahead and round, okay. Again, we're going to round to the nearest cent. Okay, so this couple is going to receive, let's do our rounding here. Okay, so we've got 3 cents here. Okay, let's look after, we've got a 0, so we're just going to keep it 3 cents. So this couple can withdraw $2,469.03 every month. Okay, so there we go. All right. So, one thing to notice, okay, it's not part of the problem, but I just want to mention it to you, okay? Remember we said when we first started working this problem, there's going to be a total of 120 payments, okay, to the couple, or withdrawals that they can make 12 times a year for 10 years, okay? If you take this amount, $2,469.03, okay, and you multiply it by 120, the number of payments, okay, you can see that's a whole lot more than $200,000, okay? Again, remember, they're withdrawing money every month for 10 years. The money that is still in the account is still earning interest, okay? So that's why this is bigger than $200,000, okay? Let's take a look at